Okay, so let's close out the chapter with something that I added, which is my favorite, and that is to use the current expertise, knowledge, investment, and workforce in weather and climate forecasting in for early warning systems for human health. Okay, so we talked a little about projections of extreme events, heat waves, floods, droughts, harmful algal blooms, and so on, wildfires. And obviously they can be converted into projections of health outcomes. But there is a very active field at a much shorter time scale where actual decisions on health can be made and are made. Okay, so this is a nice plot that probably came out of NOAA from Louis Uccellini, Wayne Higgins, and maybe Tony Busalaki, and so on. So these are the decision timescales, which show timescales of sub-seasonal to seasonal here, and there are weather timescales here going from minutes to about a week. Weather prediction is limited to a few days because of various technical details of the weather dynamics, and yet you can make longer term forecasts because ocean, which has high heat capacity and store a lot of heat, can provide memory and control climate like El Nino and monsoon and other things. Okay, so these are the time scales going from minutes to hours to days, and 2 week to months to seasons, and then out to years. So IPCC is somewhere out here in multiple decades. And here are the various warnings and alerts at forecast lead times. So warnings and alert coordination here, watches, so you can think of cyclones, hurricanes, heat waves, storms, etc. Short-term forecast, threat assessments as you get into longer time scales, guidance being issued because the skill is more probabilistic. So you can say there is a 30% or a 50% or a 70% chance of certain events. Seasonal outlooks, so you go from alerts to watches to outlooks, guidance and outlooks, and then climate projections. So you can have various sectors being helped by this. Maritime planning, agriculture, water resources, aviation, emergency management, which includes floods, droughts, fires, hurricanes, storm surges, and energy. Health is not shown here explicitly. For those who are not climate experts, sub-seasonal means less than one season, which is 3 months, like 90 days. So you have weather on let's say 1 to 10 day time scale, and there is a bridge from weather to climate. Climate is typically beyond a season, and sub-seasonal is basically the bridge from weather to climate, so it is between 2 months, between 2 weeks and months, less than a season. Okay, there is predictability. There is the ability to predict things at these time scales, and the skill varies based on whether it's temperature or precipitation and so on. So looking at the public health sector and the decision processes for heat waves, algal blooms, disease outbreaks, extreme temperatures, and cold spells, and so on. You have different time scales, weeks to months, likelihood of a significant event, seasonal to annual, and longer term. So changes in the frequency of extended periods of abnormally hot weather, changes in the conditions conducive to harmful algal blooms, and so on. Okay, so these forecasts actually can be applied skillfully to these things, and they are being done off of California, off of Maine, in the Gulf of Mexico, in the Chesapeake Bay, and so on. Here is an example of a forecast at seasonal timescale. So during 2015 and 16, there was a very strong El Nino. Again, El Nino happens here in the Pacific, where the warm waters near Indonesia, Australia, New Guinea with the Great Barrier Reef here sloshes this way, and waters which are typically cold here around Galapagos become anomalously warm. So the regions here which are usually dry become very wet, and regions here which are usually very wet become dry. And there are also signals over India, Africa, of course Australia, Indonesia, but all the way into China, Japan, US, and so on. So during that strong El Nino, NOAA issued warnings about hantavirus, plague and West Nile virus, chikungunya and dengue fever, malaria, chikungunya, dengue fever, respiratory illness, and so on here. For those who don't know, chikungunya, and these are not fun diseases at all. Dengue can kill, chikungunya can lock up your joints and make it very difficult to walk or even squat and so on. It can create some unique problems in places like India where people squat for some reason, as you know, right? So cholera, malaria, Rift Valley fever here, cholera and malaria here, and so on. Okay, so there are direct relations between climate events at natural variability timescale. El Nino is a natural variability. Okay, it happens because of natural causes. Question is how global warming is affecting El Nino, or how global warming will affect El Nino, which will it make them more frequent, more strong, less frequent, weaker, and so on and so forth, which will have health outcomes as well as rainfall impacts, droughts, floods, food production, wildfires, etc. Okay, so here are what were actually detected that happened. So there were in fact various outbreaks in India, in Africa, in much of Asia here, in the US, and all of South America. So this is an incredibly good example of how a warning system actually can be very effective in translating physical weather and climate information, predictive information, into early warnings for human health. Okay, now you combine that with the social computing that we talked about based on environmental links and human movements, then you have something that can really help managing very serious contagions and infectious diseases. Huge efforts were made during COVID to run disease models. They are called SIR and SIER models that you can look up. Susceptible, infected, or infectious and removed. Susceptible, infectious, exposed, and removed, I think. So all of them need data. Okay, so all the effort is now on making sure we have the data to do these things more effectively, so you can plan hospitals, hospital beds, PPEs, vaccinations, quarantines, and so on. So here are the various sources from which I got the figures. I left it up here so that you can go on YouTube and take this information and find the links for some of the figures that I did not show the links for. Okay, these are also good papers which will help you advance your knowledge, especially if you're doing research on climate and human health. Okay, so that's the end of this chapter. Fairly short, but a nice introduction to various aspects of direct impact of humans on the climate, direct impacts of climate on human health, and indirect impacts of humans on health via land use change, water quality change, food quality, wildfires, urbanization, etc. Okay, very well.